I'll probably have to get a second device. Alright, good morning. Morning. Alright, so good morning. My apologies. So we won't be able to do the whiteboard feature today because I'm actually using the same device to do the live stream. So we have to go along with the same procedure we did yesterday. So I'll try to get this down as close as possible. So I'll try to get it down as close as possible and then we'll begin. So let me try to get it closer. Alright, so ready now. Alright, so yesterday we were speaking about lines. So we spoke about the linear graphs and we said we have the horizontal line, the vertical line, and the diagonal line. So I don't know if you remember how to do curve sketching or graph sketching from grade 8, because I think that's the last time you did it. But for today's class, we're going to be doing some graph sketching and we're going to plot some linear graphs to arrive at the horizontal line, the vertical line, and the diagonal line. Alright, so it should be focused now. So it's focused. Alright, so when we're plotting lines, we normally have x values and y values in a table. So guys, you can head up, write your objectives. Objectives are the same from yesterday, where it says that we're going to identify linear graphs, 3 types of linear graphs, y is equal. So if you had that yesterday, you don't have to write it again. If you don't have it yet, you can just send a message in the chat and let me know, and I'll go over the objectives. Alright, excellent. So we're going to do some curve sketching to arrive at the graphs that we spoke about yesterday. So when you're doing your graphs, you're going to have a table with your x values and your y values. So how we work this now is that, remember that x is independent. Let me just write a note over here. So I'm going to write x is independent. X is the independent variable. And then underneath here I'm going to write y is the dependent variable. Alright, so what I mean by that is that whatever the value of x is, y is going to depend on x. So we're looking at the first graph in the objective. I think the first graph is y is equal x plus c. So the first graph we're looking at is when y is equal c. So that's the first graph. So it says when y is equal c. Alright, so in this equation, let me not use this one because you might not be too familiar with this. So let me start out with the one that we're common with. Y is equal mx plus c. So we're going to do y is equal c last. So when y is equal mx plus c, we're going to sketch. So y is equal mx plus c. We're going to write down some points and we're going to sketch the graph. So we're going to see if it's a vertical line, a horizontal line, or a diagonal line. So we have the graph y is equal to mx plus c. Alright, so now remember x is independent, so we can choose x to be basically any number, and whatever the value of x is, y is going to be dependent on that value. Alright, so let's use the values 0, 1, 2, 3, 4. So we have the values of 0, 1, 2, 3, 4. And normally, when we're given a graph of the form y equal mx plus c, as given here, we're normally given a gradient. So your graph, so let's say we're using the function. So we're using the function y is equal 2x plus c. So that's the 2x plus 6. So this is how the graph normally looks. So we're using the function y is equal to 2x plus 6. Alright? So whatever the value of x is, y is going to be dependent on that value. Alright, can I see some feedback in the chat? Is everybody following? Anybody wants me to go over that section where I said that y is equal mx plus c, x is independent, y is dependent? Does anybody want me to... Alright, let me just get a quick recap of what I said so far. So today what we're doing graph sketching. So if you remember from, I think it's grade 8 the last time you did graphs, you have your x table and your y. So you have your x values in a table and you have your y values in a table. And we said that x is the independent variable and y is the dependent variable. So y depends on x. We also said that y, we're going to sketch this function. Y is equal 2x plus 6. So when y is equal to 2x plus 6, that's the function that we're going to use. So y is equal 2x plus 6. So when x is equal 0, we're going to substitute the value of 0 for x, and we're going to get 2 times 0 plus 6, and that's going to give 2 times 0 is 0, 0 plus 6 is 6. So when x is equal 0, then y is equal 6. Then we're going to do another one that says, alright, no sir. Alright, so let me go over then. So what I'm saying is that we're doing curve sketching or curve plotting. So we need some points. So the points that we need are points that correspond to this function that says y is equal to 2x plus 6. So to find the y values, we have to substitute the x values into this formula. So the first one we're looking at is when x is equal to 0. So when x is equal to 0, we have y is equal to, replace the x with 0, 2 times 0 plus 6. You know, anything times 0 is 0. You add 6 to that, you get 6. So we have our first point. So our first point is 0, 6. And we plot, this is how we plot our points. So this is always how we plot our points. You always plot your points in the form xy. So x always goes first and then your y variable goes after. So that's how we plot our graphs. Then we're going to find the value for y when x is equal to 1. So we're going to substitute the value of 1. So again, so just write while I write. 2 times 1 plus 6. Now 2 times 1 is 2. Add 6, you get 8. So our next xy value is 1 and 8. Then we do the same thing going along. So we're going to 2 times 2 plus 6. 2 times 2, 4. 4 plus 6, 10. So next value is 2, 10. Then 2 times 3 plus 6. 6 plus 6, 12. Then the next value is going to be 3, 12. And the last one is 4. 2 times 4 plus 6 is equal. 2 4s 8 plus 6, 14. So that's going to be 4 and 14. So now we have the points that we need to plot the graph. So the points we have are 0, 6, 1, 8, 2, 10, 3, 12, and 4, 14. So we're going to get graph paper. And the graph paper is going to have a y-axis. Remember, the y goes from bottom to top. And it's going to have the x-axis which goes across. Then we're gonna plot. So when we plot now, we're gonna plot. So let me write some points on the x. So here is 0, 1, 2, 3, 4, 5, 6. And here's 2, 4, 6, 8, 10, 12, and 14. So when we plot our points now, the first one is 0, 6. So we find 0 here. Then we're gonna go up. So you first, when you're plotting your points, the first thing you do, you find your x. So you go on your x to find 0. So 0 is right here. And then you go on your y-axis and you find 6. So our first point is right here. Then we're gonna find 1, 8. Guys, make sure you're doing this in your book as well. So we go on the x, we find where 1 is. So this is where 1 is on the x. And then we're gonna find 8 on the y-axis. So 1 and 8 is somewhere about right there. So that's our second point, 1 and 8. Then we're gonna find the third, fourth, and fifth one. So we have 2, 10. Go on the x, find 2. Go on the y, find 10. So it's about right there. Then we're gonna find 3, 12, x, find 3 on the x. Then we go up to 12 right here. Then we find 4, 14. Go on the x, find 4. Go all the way up to 14. And our graph is going to look something like this. So what kind of line does the graph form? What kind of line is formed by our graph? So we have a diagonal line. So a diagonal line was formed. So what you can say is the shape. So therefore, so you're gonna write therefore when we have a graph, so when we have a graph of the form y is equal mx plus c, it forms a diagonal line. It forms a diagonal line. So when we have a graph of the form y is equal mx plus c, it forms a diagonal line. Are any questions? Anything anybody wants to? Yes, a diagonal, correct, Gabriella. So anybody has any questions regarding the construction of the graph? You want me to go over it? We're going to do the same thing for y is equal c and x is equal k. But I just need to know if you understand it so I can maybe pick up the pace when I do y is equal x and y is equal c and x is equal k. And then I can go back to the WhatsApp chat and put this in the chat. So for those who weren't able to access this on YouTube, then they can have it. Alright, so it's a diagonal. So what all we did was we put some x points. We had a formula that says y is equal to x plus c. Wherever we said x is equal to 0, put it into the formula. We got 6 and we got this, we got 14 and all of that. So we have our points 0, 6, 1, 8, 2, 10, 3, 12, 4, 14. And it's always in the form xy. We have our y-axis and we have our x-axis. So we find 0 on the x, find 6 on the y, 1 on the x, 8 on the y, 2 on the x, 10 on the y, 3 on the x, 12 on the y, 4 on the x, 14 on the y. So that's it. Do over the workout part. Alright, so it's a substitution. So we have our formula. So the formula for, remember I was saying that y is the dependent variable or the formula of the line, the equation of the line. So where we have y is equal to x plus 6, wherever we see the value of x, we're going to substitute into the equation. So the first one we did it when x is equal to 0. So when x is equal to 0, put 0 for x. We get 2 times 0 plus 6. And we end up with 6. When x is equal 1, we put 1 into the x. And then, yeah, when x is equal 4, and that's how we do it. So we're going to do the next one now. This graph is going to be x is so y is equal c. So this is our graph now. Y is equal c. I need to erase this page. Alright. So we're doing the one y is equal c. I need to erase this page. So y is equal c. So remember we said that yesterday we said that c is the y-intercept, or the point where the graph cuts the y-axis. Point where the graph cuts the y-axis. So that's what c is. So based on that definition, you kind of already have an idea of how the line is going to be. So as usual, we have to draw up our table. So x and y. So for this time, so whenever we're doing the equation of the line, we can't just leave it, we can't leave the m and we can't leave the c. So let's say our c, so c in this case, c is equal 6 in this case. You can make c be anything. C can be -6, c can be -5, it can be 1. It's just based on what you come up with or what the question says. So if the question says c is 8, you will do the same steps that I'm doing now. But we're saying c is 6, so therefore y is equal 6. So if you observe this, we don't have any substitution to do now. The reason we don't have any substitution to do is because we don't have an x in the formula. So we don't have any substitution to do. So as usual, x is independent, so we're going to put down some x values. So we have 0, 1, 2, 3, and 4. So when x is equal 0, so we have everything now. So when x equals 0, then y is equal 6, because y is always equal to 6. If you look at it, no matter what happens, y is always going to be equal to 6, because in this case, y does not depend on x. Y is still the dependent variable, but there is no x in this formula. So therefore, for any value of x, y is going to be equal to 6. So when x is equal 0, y is equal 6. When x is equal 1, y is equal 6. When x is equal 2, y is equal 6. When x is equal 3, y is equal 6. When x is equal 4, y is also equal to 6. So now we have our points. So our points are 0, because remember we have to put it in the form xy. So when x is equal 0, y is equal 6. When x is equal 1, y is equal 6. And x is equal 2, y is equal 6. X is equal 3, y is equal 6. X is equal 4, y is equal 6. So these are our points. So we're going to use these points to plot the graph. So we draw our y-axis and we draw our x-axis. So we're now going to plot the graph. So when we plot the graph, we're going to have 0, 6. So let's number our graph. So this is 0, 1, 2, 3, 4, 5, 6. And we have 1, 2, 3, 4, 5, 6. Alright, so when x is equal 0, so we're doing the first point, 0, 6. So when x is equal 0, y is equal 6. So 0, and we find 6 up here. So it's this point. When x is equal 1, y is also equal 6. So it's this point. X is equal 2, find 2 on the x. Go up 6 points. It's also equal to 6. X is equal 4, find 4 over here. Go up. It's also equal to 6, and likewise everything. So the graph that is formed is going to look like this. And what line is that? What line is formed? So when y is equal c, what line do we have? We have a horizontal line. So previously, we got a diagonal line when we did y is equal mx plus c, and now we have a horizontal line when we're doing y is equal to c. No, it's a horizontal. Can you remember when it's flat? Vertical is upwards. So vertical is when you're going upwards. So this is going to be a horizontal line. Alright, good. And then if you realize the graph also cuts the point, so the graph cuts the y-axis at 6. So yeah, that's it. So it's a horizontal line. So now the next graph we have to look at is when x is equal k, and you kind of already know what it's gonna be because it's gonna be the vertical. So far we did diagonal, and just now we did a horizontal, so the next one is going to be the vertical. Alright, so let's do the vertical line. So this one is graph of x equal k. Let me see what time it is, if I have enough time to go back in the group. Alright, yeah, I have enough time. So the graph is x is equal k. Good? Alright, so now this graph is a bit different. Alright, it's a lot different now because we don't have any y in it, and we know that y is a dependent variable. So how this graph goes is like this. This is how this graph goes. We have x here and we have y here. But in this case right here now, similar to how we had C, yes, a horizontal, Gabriela. I don't know why the messages are coming in so slow, but horizontal. I don't know why they're coming in so slow. Alright, so I'm gonna see if I can get a second device to use along with this one, because it seems like the one device isn't working out. But alright, so for this one, x is equal k. So let's say in this case k is 4. So I'm gonna have x is equal to 4. So similarly just now when we had 0, 1, 2, 3, 4, we can't do that because in this case we're given what x is. X is always equal to 4. So we're gonna have 4, 4, 4, 4. Now y is going to be, basically y isn't important in this case. We can give it some values, but I mean y is not really important in this case. So let's draw our graph. So remember, so let me just give it some arbitrary value, 1, 2, 3, 4, yeah. So remember in this case, whenever we're plotting, we plot in the form xy. So the coordinates are 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. Because x is always equal to 4. So we're going to plot our graph now. So this is our y-axis. And this is our x-axis. So we have 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6. Alright, so now the first point we're going to plot is 4, 0. So we find 4 on the x, which is right here. And we find 0 on the y, which is also right here, because 0 is this on the y. So 0 is this on the y, 0 is this on the x. So the first point is right here. Then we're going to find 4, 1, which would be 4 on the x, 1 on the y, right here. 4, 2, 4 on the x, 1 on the 4 on the x, 2 on the y, right here. 4, 3, 4 on the x, 3 on the y, and then 4, 4. So this is not drawn to scale, but it's supposed to be a vertical line. So this is a vertical line. So if you see that now, so that's how we get the vertical line. So you can say the graph of x is equal k forms a vertical line. So the graph of x is equal k forms a vertical line. So let me know if you need me to answer anything. I'm gonna give a summary. So yeah, so the chat is slow. But alright, so I'm gonna give a summary. I'm gonna go over everything. So you should have the notes. I'm gonna go over everything in summary. So summary. Alright, so just now we looked at linear graphs. So we looked at linear graphs, and we said the linear graphs are, oh, what's happening with my battery? So we said the linear graphs are horizontal, vertical, and diagonal. So which graph is the horizontal graph? Y is equal C, y is equal mx plus c. That's what we just found out. So when we plot, we realize that for the diagonal line, that's y is equal mx plus c. For the horizontal line, that's x is equal k. And for the vertical line, that's y is equal to c. And you don't have to remember the formulas or anything. You can just plot them. Whenever you plot them, you realize that you can get them easily. So all you have to do is just plot them. You draw up your table, and we say whenever we're plotting the lines, we plot them in the form xy, where you put the x value first, and then you find the y value and you plot your lines. So if you have your y-axis and you have your x-axis, you plot them based on x and y coordinates. Alright, so I think that's really the general idea of everything. I assume you guys have graph paper. So what I'm going to do, I'm going to go back to the group now, and I'm going to give an activity for you guys to work. But before I go, I'm going to show you how to calculate the gradient of the line algebraically and on the graph. So gradient of the line, so we're at the second, I think it's the third objective. Gradient of the line. Gradient of the line. So what is gradient? First we have to define what gradient is. So the gradient of the line, alright, let me say a line. The gradient of a line is the steepness or slope of the line. So the gradient of the line is just the steepness or the slope. What I mean by that is that, let's say you have a hill with a gradient that is very high. Let's say the gradient is something along the lines of 50, would be steeper than a hill with a gradient of maybe like 2. So the higher the gradient, the steeper the hill. So let me just write that. So the higher the value of the gradient, so the higher the value of the gradient, the steeper the hill is. Steeper the hill is. So therefore, if a hill is flat, it has a gradient. It has a gradient of 0. So if a hill is flat, it has a gradient of 0. Alright, so I'm going to read it over again. So it says, the gradient of a line is the steepness or slope of the line. The higher the value of the gradient, the steeper the hill is. Therefore, if a hill is flat, it has a gradient of 0. So therefore, if a hill is flat, it has a gradient of 0. Also, final note, if the gradient is negative, guys, I guess this is kind of why it's better when you have to face, because this question is actually for you to answer. What happens if the gradient is negative? But no, and the chat is moving. Alright guys, can you type it? What do you think happens if the gradient is negative? I don't want to give you the answer just yet. What happens if the gradient is negative? Yeah, I'm going to give you guys one to try. What happens if the gradient is negative? Alright, so the final thing I'm going to say is if the gradient is negative, I'm going to give one in the group. If the gradient is negative, then we say the hill is downward sloping. Gradient is negative, then the hill is downward sloping. That means it's downhill. Alright, so that's as much for the notes today as we're doing. We're gonna move to the group now. I'm gonna send what I did here, and then sir, you can send the last part in the group. Alright, so I'll send